We are going to be looking at another type of conic section, and that's a hyperbola. A hyperbola is kind of similar to a parabola in that it has a U branch, but there's actually two of them, and they join together. We're going to look at the graph first, so that way maybe the equations come a little bit quicker of what we're looking for and how to find stuff. We're going to start with x squared over 9 minus y squared over 25 equals 1. So similar to what we've been having with our ellipse, we have a center at 0, 0. The a squared always for a hyperbola stays on the left. With an ellipse, it could move. So our a value is 3 here, and our b value is 5. Now the c value is found a little bit differently. We have a different Pythagorean relation, so that's just something to note. It is actually your true Pythagorean theorem of a squared plus b squared equals c squared. So that's just something to consider. When we have our information like this, in that we have a center of 0, 0, we're going to sketch this based on the a and the b value. So the x is going to be based on the a, because x is coordinating with that a value, and then the y is based off of the b in this situation. So what we're doing is we are, based on our center, we're going to kind of graph those lines. So we have x equals plus or minus a. So I'm just sketching these in. There's a very straight line there at the end. So notice here, we have a rectangle shape that ends up in the center with a center of 0, 0. So this information is useful because this is what our hyperbola shape is going to kind of curve around. Now, notice it says that the asymptote lines on your formula sheet are at, in this case, negative b over a plus or minus technically, and x. Well, realistically, that asymptote is realistically going from corner to corner. Just giving you an idea here. So notice I've got 3 points that I can sketch those asymptote lines through. To kind of help, I'm going to shorten this up a little bit so it's just that box. You can leave yours there. It's not a big deal, so don't feel like you need to erase that. All right, so I've got my asymptote lines drawn in roughly here. And then you're going to use the rectangle and the asymptotes to guide your drawing. So what that means is we're going to be touching, we're going to have a vertex here and a vertex here. And then the asymptote, it's going to curve around that asymptote line and come in close and then next to it. But notice I go right up to that rectangle box to hit that vertex. And that's where it's sketching. So the blue here is my rough sketch. If you wanted a more precise sketch, you could graph it on Desmos and then get some information like different points to locate. But let's talk about the actual graph of this. So like I mentioned, these points here in blue are your vertices. This point in the middle is our center. And then we'll have a point, technically I could calculate it. The c value is going to be kind of a nasty square root. But you'll have a point, we're just going to throw it on here. You'll have these points here, which are your foci points. Again, that's what it's curving around from there. And obviously, we drew these in we have the asymptote lines there. So notice here, between the vertices, halfway between the vertices is going to be your center. Halfway between your foci is going to be your center. So that's good information to have in regards to the next part that we're going to be talking about with the equations. So let's say that we have an equation of x plus 3 squared over 4 minus y plus 2 squared over 1 equals 1. So we're going to find the center, the vertices, the foci, and the asymptote line. So the center, probably the easiest one. Remember, it's opposite of what you see, so it's -3, -2. The vertices. Now, I need to know my A, B, and C values. So again, A is always on the left. Therefore, A is going to be 2 because it's the square root of 4. B is the square root of 1, which is 1. Now C. C is realistically the square root of A squared plus B squared. So in our case, the square root of 4 plus 1, which is 5. Okay. Now that I got this information, it's going to make the vertices, foci, and asymptote lines a lot easier to find. So the vertices we have, because the x is first, we're going to follow that left side. So everything's adjusted with the h. So we have -3 plus or minus 2 comma -2, which is realistically going to result in -5, -2, and -1, -2. Our foci, -3 plus or minus the square root of 5, comma -2. Since it's the square root of 5, I'm not going to break that down. It doesn't gain me anything, right? It's just an extra step. Asymptotes, y equals plus or minus, we have b over a, so we have 1 over 2 x. So that's the information you'd be looking for based on your equation. You have to do a little bit of math in order to figure out your c value, but not bad. Sometimes you won't be given the equation, you'll be asked to find the equation based on different characteristics, which we've been doing before. So let's say that we have vertices at 2, 0 and at 6, 0. And then we have some foci at 0, 0 and 8, comma 0. Okay, so looking at our equations here, the x value, or the h, is going to be the one that's adjusted. Because notice we had 2, 6, 0, and 8, where all the y coordinates stayed the same. Therefore, we know that we have a horizontal. Okay, which means that the x value is first. Okay, so we're following that left side there. Going back to our graph, remember that the vertices and the foci, they give us our A value and our C value. So the distance between foci, so we're going from 2 to 6, which means that we have a distance of 4. Foci relates to, oh, I have that wrong. I'm looking at the vertices, and then instead I said foci. Okay, the distance between the foci is 0 to 8, so that's 8. Therefore, we know that the C value is 4, because we're cutting that in half. The distance between the vertices is 4, therefore A is 2. Okay. Now the other thing that we can figure out is the center. So if we cut the distance in half between them, we get a center of 4, 0. Okay, which makes sense. So now we have enough information that we could pretty much write it out, except for we need that b squared. So again, c squared equals a squared plus b squared. So in my case, I'm going to do c squared minus a squared equals b squared. Remember, you just need the b squared, so it doesn't matter what b actually is. So we'd have 16 minus 4, which equals 12. Okay, now I can actually write my equation. X minus 4 in parentheses squared over 4 minus y minus 0 squared. Again, you don't have to list it as a minus 0. It's fine. Over 12 equals 1. So we're just using our different characteristics based on, what we know about the graph in order to figure out an equation and find those A, B, and C values and find that center based on our characteristics. So the graphing side of things, it could get a little bit tricky if you don't have a center at 0, 0. But like I said, you could always base that off of your Desmos and that kind of information.